So I'll switch to some work by my group, and I'll start with a quiz. We are in a university setting after all, so here are two quotes, and I'll give you a second to read them. So the first was from 2019, and the second is from 2022. And both of these quotes are both statements are by the same person. So the question is, who made them? Any takers? Excellent. So here is your Elon Musk. So autonomy is indeed a hard problem, and self-driving cars are supposed to be easy, right? Because they have great sensors. They operate in well-mapped and structured terrains. They have relatively few objects to recognize. Imagine driving an autonomous vehicle in a fairly unstructured terrain, so that's much harder. We do know, however, that animals, humans can do this quite well. So perhaps part of the solution, part of the answer may be that we need to better understand the science of animal and human navigation and try to teach autonomous systems using these types of lessons. And there is some work of this type that is being done here at BU. We have another center on, we call it a Neuro-Autonomy Center, supported by a large ONR MURI grant, working on bio and neuron-inspired navigation. So in my group, we work on methods to learn navigation policies from human data, leveraging the data in order to better train autonomous agents. In some of the recent work that we have done, we have been able to achieve human-level performance with an autonomous agent using data from a video game like this. So this is joint work with Chantal Stern and Mike Hasselmo. We've also been working on policy optimization methods. So these are reinforcement learning methods, joint work with Christos Kassandras and some of our students. And in this type of policy optimization methods, you start with some initial policy, and then you collect data by applying this policy. And you use the data to improve the policy, compute gradients, use gradient-like methods to improve the policy. So here you can see on the left an agent that has not been trained with a robust policy and doesn't do very well. And on the right is an agent that works using a more robust version of these policy optimization methods. When using data in order to improve policies, there are issues also of sample efficiency. You would like to use the samples in the most efficient way. And again, you see on the bottom an agent that doesn't use a sample efficient method, or where on the right, an agent that uses a sample efficient method and can converge much faster to a good policy and get to the goal of the agent much faster. We're also working on theory of reinforcement learning, particularly using neural representations of policy and value functions. This is joint work with my colleague Alex Olszewski. And that's the overview. Many students, current and former, have contributed to this work, and also collaborators here at BU that are being listed and from whom I've learned a great deal. Thank you very much.